Today we're going to be covering another Amazon's interview question. This is Leetcode question number 61, a rotate list. We have been given a list. We have been told that we need to rotate it by two indices or two elements. So one would move over here, two would go over here, three would go over here, four would be moved to this place, and five would be moved to this place. In order to do that, again, we need to, the way I would suggest is basically we're gonna handle the base condition here. Uh, if the head is equal to null or the head dot next is equal to null, don't have to do anything, just return the head. We're gonna have a copy of on the head, right? Look at, I'm hoping you can see my mouse here. Okay, let's just do our own one over here. So the head is equal to 1. We're going to make a copy of that. That would be first. That is also 1. So our head is sitting here. Our first is sitting here. So the length is equal to 1 at the beginning, of course. Right. You're going to go through all of it, the first one, while the first one's next doesn't become equal to null. So we're going to go 1. We are already 1. So that's going to become 2. Right. So 2. Basically, we're trying to know how many elements do we have. Or linked list elements do we have, linked nodes, list nodes do we have. So we have 2, 3, 4 and 5. We're going to stop here because the next is null now, right? So that being said, we got the length. The total length is just 5. That's what why we did it. Then we're going to say that the first dot next, we are sitting here, right? We're going to say that the first dot next is equal to uh, first dot next is equal to head. That basically means that if they are pointing, the 5 would initially was pointing to null. We said no, it's not gonna point to null anymore. Now it's gonna point back to the head. Now it's a circular linked list. So when we did that, all we need to do, because the k can be more than the number of elements we have, so we don't need that. So we're gonna take the modulus of that, so that we are, because, and you can look at it, that in this example over here they did it 4. So rotating it 4 times is actually equal to rotating it how many times? 1 time, because k modulus of 3 is equal to 1. So if we would have rotated it 1 time, it's gonna give the same effect if you keep rotating it 4 times. So we're gonna have a fast pointer to the head, slow pointer to the head. So again, this was first. So we're gonna have another one, fast pointer to the head, slow pointer to the head. Then we're gonna say that, okay, whatever the k is, first move the move the uh, move the fast that many times. Just iterate fast pointer that many times. So let's say that the k was, in our example, k is 2. So we're gonna say that slow is just gonna keep sitting here, fast is gonna move 2 times 1 and then 2. Once we do that over here, we just didn't touch the slow one and moved k times fast. Then we're gonna say that while the fast is not equal to first, right, we are gonna keep moving both of them. Okay, so move it once together, move it twice together. So you moved it. Now fast has become equal to right, fast has become equal to So fast has become equal to first. Okay, so the last thing you need to do is to actually say that the slow dot next, this is the slow dot next, is gonna become equal to null. So you're gonna say, if I can just copy everything here, what we're gonna be saying is that this thing over here is gonna say that this is gonna be null, right? We're gonna be removing that and saying that this is null anymore and they are disconnected. And the thing which you're gonna be returning is the result. Oh, we just created the result. So the list node is the result slow dot next, right? And just remember that what is gonna happen. So this first is moved here. So before actually doing this last step, which we just did this, right? So we are saying that keep the record of this 4, call it result, and then make the 3 dot next or the slow dot next equal to null. That's it. And then we're going to be returning the result. Oops, that would be 4. And if I just straighten it up, it's going to be 5 4 5 1 2 3 null. That's what we're going to be returning, and that would be the answer. In terms of the complexity, we're not really using any extra space. We are going through a couple of times, still linear. So basically in linear time complexity we can solve this problem, and yeah, we are not really using any extra space. And that's all I wanted to cover in this video. Thanks for watching.